Okay, Assalamualaikum and very good day to all of you. So today we're going to continue for chapter 2, which is consists of two parts. Okay, so in this part 2 we will cover about equilibrium of a particle and a free body diagram. Okay, so let's continue. So first of all, what is equilibrium of a particle? Okay, so equilibrium words here is to show that the object or the particle is in equilibrium condition. Okay, so what is happened during this condition? Okay, so for your information, when the particle is equilibrium, okay, the resultant force, the total resultant force is equals to 0. Okay, so remember that before this we learned how can we calculate the resultant force, the Fr. Okay, so in the case of the object or particle in a condition of equilibrium, okay, so this resultant force, okay, will be equals to 0. Okay, so for example, okay, in this diagram it consists of two forces, okay, with the same magnitude. So when the particles A, it is in equilibrium, okay, the force, okay, these two force, because it only has two force, okay, the force supposedly should be equal magnitude, the same line of action and opposite sense. Okay, let's check it one by one. Okay, so equal magnitude, okay, so it both has the same value of force, 100 pound and 100 pound, okay, and the same line of reaction. Okay, so look at this is, for example, this is a line of action. Okay, so both of the force occur at the same line of action. So for example, okay, let's say the first force is at 1001, okay, and the second force, still 1000, okay, but the second force also 1000, but the force occurred not at the same line of action. See, so it's not same like this one, so this one will not be in equilibrium. Okay, so that's why for the particle, for the force acting on a particle which only has two force, okay, in order to be equilibrium, it's supposed to have the same magnitude and the same line of action and opposite sense. Okay, alright, now take a look at the force, the particle which has more than two force. Okay, so for example, in this case, it has four force together, which is F1, F2, F3, and F4. Okay, so what happened is when the particle acts upon by a three or more than two force. Okay, so for example, more than two force. Okay, by using the graphical solution, okay, or the rectangular component method, okay, we will get the summation of force, or the R value supposed to be equals to 0, and the summation of Fx should be equals to 0, and summation of Fy equals to 0. Okay, so in summary, I can say here that for the particles to be in equilibrium, okay, what happened that in that condition, the Fr, or the resultant force, supposed to be equals to 0. Okay, okay, so let's proceed with the next part. Okay, let's continue with the part of free body diagram. Okay, so basically in this part we will learn how can we construct the free body diagram, or how can we convert the diagram into free body diagram. Okay, so for your information, free body diagram is a diagram in which we simplified it from the schematic diagram in order for us to solve that particular problem. Okay, so in order to construct the free body diagram from the schematic diagram, there are 3 important steps that you should do. Okay, so the first one is you need to identify first what is the problem. Okay, so for example, in this case, the problem may ask you what would be the force should be exerted on the along the OBA part. Okay, so we notice that this OBA, whatever it may be like, part here, the OBA, okay, is being applied with 3 different forces, okay, like M and B here and on O itself. Okay, so you have to identify from that problem what is actually our concept or our reference. Okay, are the question referring to this part or this part or any other parts? Okay, so which one is the object or particle that we want to consider from that question point of view? Okay, then after that, after we identify what is the problem from the question, okay, so you need to isolate the object, okay, or simplify the object to a rigid body or particles. Okay, so for example, in this case, it's focusing on this part, the middle part here. Okay, so you just isolate the object that we want to focus. Okay, instead of focusing the whole thing. So you know that, okay, you want to have a look at the along the OBA part. Okay, and then after that, okay, sketch all the external forces involved. So for example, on this part, okay, you have to identify what is the external force involved on this part. Okay, so for example, from here we understand there are M, okay, on the vertical direction, and B here, which has an angle, so maybe the force at O. So you have to sketch all of these external force on your object that you already isolate just now in step 2. So let's take a look. Okay, so for example, here, so in this case, there are mg here. So why do this question put the mg instead of m? Okay, so we know that the mass can only convert into force, okay, by multiply with the gravity acceleration. So this one is actually mg. Okay, and then it has another force here, okay, which is pulling on the left side due to the rope. Okay, so in that direction. Okay, so therefore this is supposed to be our free body diagram of this part. Okay. Okay, let's try to solve this example 1. Okay, so read the question here. Okay, in a ship unloading operation, a 3,500 pound of automobile is supported by a cable. So this is the automobile. It is supported by a cable here. Okay, over its intended position. So what is the tension in the rope? Okay, so what will be the tension in a rope here? Okay, so this is what we call the schematic diagram. So before we can solve the question about the force, okay, how much we have to put the tension here, okay, you have to convert first the diagram into free body diagram. Okay, so let's take a look. Okay, so for example, in this case, okay, we are focusing on the particle or the point at A here. Okay, so actually there are force which is 4 pulling outward because it is tension. Okay, so this man is actually pulling it by using a rope. So that's why if you look at the diagram here, okay, the force is marked as TAC with the degree here, with the angle from the x-axis is 30 degree. So it's same like this one. Okay, and then okay, since we focus on the particle at A, okay, so there's another force here which is due to the TAB, the tension by the rope at TAB. Okay, so the angle between the Y and the TAB is 2 degree. Okay, so this is the second force, and the last one is actually the weight of the automobile here, which is the weight of the loading here, okay, which is 3,500 automobile. Okay, so because the weight is always pointing downward due to the gravity force. Okay, so that's why it's just in a vertical direction due to the weight of the body of the automobile. So in order to solve this, okay, there are two methods. Okay, if you still remember before this in part 1, okay, in order for us to solve it, okay, we either can use the trigonometric rules or the rectangular component. So in method 1, let's solve first with using the trigonometric rules. Okay, so how can we convert this FBD into this trigonometric method? Okay, so let's take a look. Okay, so example in this case, okay, actually our objective is, or our the focus of this instrument or system, actually we want to lift up the automobile. Okay, so actually this resultant force, okay, should be considered for us to make another lift up force, okay, in order to pull it up into the ship. Okay, so therefore this one is actually considered as resultant force. Okay, so that's why the resultant force is actually due to the weight of the automobile, which is straight downward with value 3,500 pounds. Okay, and then okay, this this car is then being pulled by another force here, which is by this man, which is downward, which is called the TAC, tension, okay, at TAC. So that's why it is being pulling downward by TAC with the angle equals to 30 degree. Okay, and then we know that, okay, the TAB also connected, also being used in this case. So we have to connect between the TAB with the rest of the force. Okay, so since we know that the TAB is in this direction, okay, and the angle from the axis Y here is 2 degree. So that's why we just put that this one is actually 2 degree. Okay, and then you have to work out with all the value of the force, value of the angle inside. So since this is a 90 degree, okay, and the angle here is 30 degree, so the total angle here is actually 90 plus 30 degree. So it's become 120 degree. Okay, so we know that the total angle in the triangle should be 180. So the remaining angle here is 50 what is the TAB and what is the TAC. Okay, so from calculation, after you solve it through mathematical calculation, you will get your TAB is 3,570 pound and your TAC is 144 pound. Okay, so done with the method 1 by using trigonometry method. Okay, so now let's take a look at the second method, which is by using the rectangular component. Okay, so now we refer to the second method, which is the rectangular component. Again, we still have to use this free body diagram. Okay, so in all together there are 3 forces, okay, acting on a particle A or point A, which is the force due to the TAB, okay, and the force due to the TAC, and the force due to the weight of the car. Okay, and we know that if the car is considered, or the point, sorry, it's not a car, if the point A or particle at A considered in equilibrium, it means that the summation of Fx will be 0 and the summation of Fy will be 0. Okay, therefore we have to segregate all the force involved, okay, using the XY table like this. Okay, so remember this one is actually the force, the Fx, and this one is actually the force in Y direction. Okay, let's take a look at the first one, which is the TAB. So the TAB is located here, okay, with the magnitude which is not known, which is unknown. So that's why this one I just leave it as a TAB, which is unknown. You have to find that value. So just refer to the TAB here. So in order for the TAB to be in X direction, okay, so we will resolve it. Okay, it will be like this. Okay, so this is the TAB. So the force in X direction will be at this point, and the force in Y direction will be at this point. Okay, and this is the 2 degree theta. Okay, so by referring to this theta, okay, the Fx for the TAB is actually can be get by multiply the TAB with the sine 2 degree here. Okay, so this one will be your Fx. The same goes to Fy. So for the Fy is actually the TAB times with the cos, because the Fy located on the adjacent part. Okay, so same goes to the TAC. Okay, look at the TAC here. So the triangle will look like this. Okay, this is the TAC, and you have the angle here, which is 30 degree, and then this is your Fx, and the Fy is at this point. Okay, so that's why since the Fx located on the adjacent side, so for the Fx it should be the TAC times with the cos 30, and for the Fy it should be TAC times with the sine 30. Okay, so look at this one. The Fy since is on a down part side, so that's why it has a negative sign. Okay, and same goes to the TAB here, because it is pointing to the left, so that's why it has negative sign here. Okay, now look at the weight. Okay, weight is just involved on the y-axis. That's the reason why, okay, the magnitude is 3,500, and since it's only involved the y direction, so here will be 0. Okay, what about the Fy? Okay, so for the Fy it's become minus 3,500 because it is in negative side. Okay, so since our objective is we want to get what is the TAB and TAC value if the A is in equilibrium. So therefore we know that if that point is considered equilibrium, so we can use this equation. So summation of fx should be equals to 0. So look at the fx column. Okay, so fx is consists of minus tab sine 2 degree plus with TAC cos 30 equals to 0. So here we have one equation actually. Okay, and after we simplify it, okay, so we can make the equation into this form, simplified form, which is TAP equals to 24.82 TAC. Okay, so done with the relation which is involved from the fx equals to 0. Okay, now take a look at the fy equals to 0. So the fy equals to 0 is actually we get it from whatever value which is along this column. Okay, so that's why fy equals to 0, which is involved the tab cos 2 degree, this one, and then TAC minus TAC, which is this one. Okay, and then 3000 minus 3500 because it is in negative value. Okay, so just put it here. Okay, and after you rearrange the equation, okay, you will get that the TAC equals to 145 pound. Okay, so this one is actually equation 2 in which we develop from this main equation of Fy. Okay, so we substitute the TAC value into this equation 1, and finally we will get the answer for TAB. Okay, so I repeat, okay, for the sample for the particle in equilibrium, if we want to solve it by using the rectangular component, we should use this equation, these two equations. The first one is fx, summation of fx equals to 0, and the second one is summation of fy equals to 0. Okay, and then we solve the first one by one and identify what is the unknown value. Okay, then you combine it together with these two main equation from the equilibrium condition, and finally you will be able to solve your desired value of unknown value that you want to find. Okay, that's it. Thank you.